Hello everyone, we are Group 3 and our presentation is on supply chain on optimization predictive analysis for ETS devices. To set the context, ETS devices is a US-based distributor supplying IT and technological equipment and their scale is a major driver of complexity. ETS manages over 25,000 SKUs, which makes manual tracking and decision making inefficient and error prone. In the US distribution market, where competition is intense, small improvements in inventory control and ordering decisions can have direct impact on profitability and service levels. Now, the operational challenges. Next slide, please. The
We are
operational challenges has three key parts. First, dynamic pricing. Pricing structures change frequently, often bi-weekly and monthly, so manual monitoring becomes difficult to sustain. Secondly, profitability and order decisions. With thousands of products, ETS cannot easily identify which items are truly profitable and what the optimal order quantities should be across the catalog. Third, the company operates under important constraints. Uh, Particularly delivery costs and minimum order quantities, which limit flexibility and distort ordering decisions if not modeled properly. Now, Shariar will continue.
Thank you so much, Osama. So, starting off, how we did this. So, starting off for demand predictions, we implemented a random forest regression model using orange data mining. Random forest was selected because it performs well with non-linear relationships and is less prone to overfitting compared to simple regression models. Also, the model generates robust and stable sales forecast that serves as a reliable input for our profit optimization stage that Essen will show and discuss in the upcoming slides. Moving forward, due to the shortage of time, so our analysis is based on historical sales and vendor purchasing data. We used over 1200 sales transactions and more than 150 purchase orders. To prepare the data, we match sales records with the vendor cost to calculate accurate unit cost at the SKU level. We also incorporated selling and fulfillment fees to determine net profitability rather than gross revenue. Finally, we standardized date formats to enable time series analysis. This ensured the data was clean, consistent, and suitable for predictive modeling. Over to you, SM. Thank you.
Okay. Once our data was cleaned and processed, we moved to the core of our methodology, the prediction phase. We utilized the orange data mining to build our model specifically. We choose the random forest regressor. We selected random forest over simple regression for two main reasons. It is highly resistant to overfitting. It handles non-linear relationship much better, which is crucial given the complex variables we are tracking like seasonality, sales velocity, and the changing unit cost. Next slide, please. The result of this model was very highly encouraging. Looking at the metrics, we achieved an R score of 0.946. This means our model explains nearly 95% of the variation in the sales revenue, giving us the high confidence in the prediction. Additionally, our RMSC root mean square error was remarkably low at 2.7, indicating that our predicted sales values are very close to the actual figures. As you can see that scatter plot, the correlation between the actual and the predicted sale is tight. Next slide, please. Okay, with accurate predictions in hand, we move to the phase two, which is optimization. We use Excel solver to answer the most critical business question: how much should we order to make the most money? We set our objective to maximize total profit, set subject to the three real world constraints. Our budget was around 1.2 million. Demand, we cannot order more than the forecasted demand per SKU. The MAQ, we must have a minimum 10 units order for each SKU because it is a policy, company policy. So in regarding these all constraints and the objective, we achieved a 500 $2,281 optimal profit. So it was our optimal profit. So moving to the next slide. To look at the bigger picture, we also performed a time series analysis using Arima to forecast the next 2 months of our sale. Using CUSUM analysis, we identify a dropping tendency or underperformance in the first half of the data, followed by a recovery and stabilization in the period of second half. This revealed a key insight: the profitability of ATS is volume driven, as profit trends were shown to lag slightly behind sales trends. Next slide, please. In conclusion, this project provides a strategic shift for ETS devices. We have moved to company from reactive manual tracking to achieve active planning or proactive planning. By implementing this system, ETS can now automatically identify profitable SKUs and preemptively organize inventory batches. This results in a truly resilient supply chain model that integrates the power of AI with the mathematical optimization. Thank you from our side. This was it.
Thank you, Allah Hafiz.